So let's see, the first part wants us to do I guess more just operations on square roots and radicals. They call it. Okay, so we kind of did some stuff with multiplication, but today it's going to get a little bit more complicated. So let's first start out with addition and subtraction. So as I was saying last time, the square roots and radicals are a lot like fractions. Okay, so they can be compared to fractions as far as being simplified. They have to be simplified, and also with addition and subtraction, because with fractions you have to have a common denominator to add or subtract. With radicals you have to have a common number underneath. So for example, here we can add these, all right? So if you have a square root of 5 plus a square root of 5, that's going to give us 2 square roots of 5, okay? So those ones we can add. But something like the square root of 5 plus the square root of 7, we can't add, because the numbers underneath here are not the same. And we can't get them to be the same, so we don't even add this. We just say this is done. So the idea here is it's quite a bit like a fraction or a variable, in that these things have to be the same in order to add them or subtract. If they're different, then we can't do it. Okay, and we cannot get them to be the same, so we just leave it alone. Okay, so then if we have something like this, and sometimes it helps to kind of say it. So if we have 3 square roots of 6 plus 4 square roots of 6, we're going to get 7 square roots of 6. Not 7 square roots of 12, 7 square roots of 6. All right? And subtraction works the same way. You could have a variable. Doesn't matter because it's the same. So we have 1 here, basically. There's no 1 there, but that's what that is. So it'd be 4 square roots of 5x. All right. So the bottom line is they got to be the same underneath there. You can't add or subtract them. Okay? They got to be the same. All right, what about multiplication? We're going to save division for a little bit. Okay, multiplication. Let's look at it from a couple different ways. First of all, we already did some multiplication like this. I know that can be simplified, but I just want it for this case, I'm just going to leave it. All right? So we got to multiply the numbers on the inside here. Okay? What happens if we have numbers on the outside? And again, I know this can be simplified, but I just want it for the sake of the problem show you what we're doing. Okay, so we're multiplying the numbers on the outside, multiplying the numbers on the inside. All right? That's how we get that answer. We don't want to mix and match them. It's going to be on the outside, it's going to be on the inside. So now let's do some problems like what you're going to see then. Okay, so let's stick with the multiplication for a little bit. So something like this, okay? This one's kind of a distributing problem, so we're going to distribute. But since this 3 is not inside a radical, okay, we can still multiply these. It's just that we don't multiply the 3 and the 2. All right? So what we're going to end up with is 3 square roots of 2 here. Okay, so we don't want to multiply the 3 and the 2 because the 2 is underneath a square root, so we can't multiply it by that 3. So 3 is just going to jump on the outside. Here, we can multiply that to get the square root of 12. And every time you do any sort of operation, all right, we're going to simplify. So we have to make sure that we're breaking these down at the end, okay, and simplifying them. They'll be wrong otherwise, so make sure that you simplify them. I can't add those because 2 and 3 aren't the same. The numbers underneath the square root are not the same. All right, so that's how you would do a distributed problem of that way. So we're going to multiply, distribute that inside, make sure you're multiplying the right things. Let's try some more. Okay, in this case here, we can multiply these two things because we have a 5 and a 5, so that we can multiply the numbers on the inside, right, or what's underneath the radical. So that would be 2 square roots of 25. I can multiply here. That's going to give me a square root of 30. Now I just got to check to see if I can break anything down. Right? What can we do here to break things down and simplify it? Right. So what is the square root of 25? 5. So that 5 comes out and multiplies with this 2. Because this is all multiplication here. So 5 times 2 becomes 10. Can we break the 30 down? No. So we leave it. Okay. So the square root of 25 is 5. That 5 comes out multiplied by this 2 and gives us 10. The square root goes away. It's not there anymore because you took the square root of 25 and got 5. All right. A lot of times that causes confusion, and I end up getting the square root of 5 someplace in that, but it's gone. Okay, because you took the square root of 25 and got 5. So the square root goes away. Okay, so let's try one like this. So it's a little bit more confusing, all right? But we just got to make sure we're going to kind of follow our rules here. So, multiplying these two, what are we going to get? 2 square root 18, right. So we're going to multiply the numbers on the inside, right? Okay, the 2 has nothing to multiply with here. Okay, so then That's going to be that. All right. Minus, what about here? What happens? What do we get? We're going to get 4 square roots of 30. So now we're going to multiply the numbers on the outside here and here. Multiply the numbers on the inside here and here. And that's where the 4 square root of 30 comes from. Okay, so we're multiplying numbers on the outside, multiplying numbers on the inside. Is this done though? Can we simplify anything? 18, right? We can simplify the 18. Okay? What the heck happened there? Oh man. Here we go. Okay, so we're going to simplify the 18. What's that break down to? 9 and 2. Okay? So, what is this going to be here? This whole thing now is going to change to 6 square root of 2 minus, right, because 30 can't be broke down. Again, that's done because we can't do anything. The 2 and the 30 aren't the same. Okay, so that's kind of what some people are, a little bit like that one we had over there with the square root of 8x, and people say, well, what happens to that 2 when you take square root of 4? Well, it multiplies. So that's what we're seeing here, is that we're breaking this down to 9 and 2. Square root of 9 is 3. That 3 goes to that 2, and they multiply. Because this is all multiplication. When you have a number next to a square root, it's multiplication. And that 2 is left over. Okay, so let's step it up just a little bit more here. Okay, now we have a situation like this. What do you think we do here? Foil it. Yeah, we're going to foil it. Okay, so we're just going to take one thing at a time, see what happens. All right. So obviously we're going to get 8 there. What's the next thing? What are we going to get here?
Minus 2 square root of
2 square root of 3. Good job. Okay, and then here, what are we going to get? 4 square root of 5. Good. And then our last one here, we're going to get. Okay. Now, so now we did that. We want to check to see, hey, can we combine anything? Can we simplify anything? Can we do anything? Can we simplify anything? No. Can we combine anything? No. That's done. So it looks like a mess. All right. It doesn't even look like we did anything to make it any better. But that's what it is. All right. We multiply the numbers on the outside. We multiply the numbers on the inside. All right, let's do something like this. This is actually a little bit simpler. So we're simplifying, again, what we're going to foil. So what are we going to get here? So we got 3. There's our 3, yeah. Now let's do the second one. 2 square roots of 7. Good, because 1 times that, there's nothing to really multiply there. Okay, now we're going down here. Minus 3 square roots of 7. Good. And then our last one. Plus 2 square roots of 49. All right, so now we got that. Okay, so then the next thing we ask ourselves is, all right, can I simplify anything? Is there anything here we can simplify? Yeah. What can we simplify? The what? The 49 at the end, right? Okay. So what is this now going to become if we know what the square root of 49 is? It's going to become a 7's going to be 14, so that's going to be 14. All right. So now, can we combine anything? Yeah, we can combine these two things. Good. So what is that going to give us? Negative 5 square root of 7. Anything else we can combine? We can combine the 3 and the 14, right? So it's a good idea to do that simplification first and then combine. All right? I mean, square root of 49 is 7. 7 times 2 is 14. This is just multiplication. Yep. And a lot of times that's how these are going to work out. Okay? Okay, so we'll try another one here. Again, we're going to FOIL. So what are we going to get for, what's our first number going to be? Three. Yep, good. So we have 3. There's our 3. Okay, now we got to go there. So what's that going to be? 3 square root of 6. Good job. Okay. Now we got this one. What's that going to be? Oh, interesting. Okay. And then now we have this one. What's that going to be? 3 square root of 36. Okay, so then you say, all right, can I simplify anything? Because that would be the next thing I want to do. Yes. What are we simplifying? Square root of 36. That becomes?
6 times 3, which is 8.
Very good. So we get a negative 18 there. Okay. Now I'm writing a lot of stuff out. You know, you probably don't have to when you're doing your assignment, you know, because you'll be able to see what's going to happen here next with these guys. Yep, those are going to cancel out. Very good. So what are we left with as an answer? Negative 15. Yep, good. So simplify, you know, combine stuff if you can. Okay, now that I have something like this, this is one of the more difficult ones. In this situation where we have square roots all over the place, all right, we're still going to FOIL, nothing changes there. Okay, so what are we going to get for this first term when we multiply these first two? I agree with the 6.
6 square root is 49.
We're going to get 6 squared is 49 because we got 7 times the 7, right? So when we're multiplying 3 times the 2, you guys are seeing that. 7 times 7 is 49, so that's got to go there. Okay, so what's our next one? Now we're going to go way over to here.
That's 15 square roots of 70.
15 square roots of 70. Okay, so again, the 3 and the 5 and the 7 and the 10. Outside, inside, those, that's what we're going to multiply. All right, now let's go with this one. What's this going to be?
That's going to be minus 2 square roots of 70.
Okay, good. All right, and then we've got the last two here.
Minus 5 square roots of 5.
Get away. Okay, so again, we're multiplying what's underneath the radical. So, oh man, that's what a mess. But again, we want to see if we can simplify things, maybe something to simplify for us. We got 6 and 49, right? So what does that become? 42, because the square root of 49 is 7. Okay. What else is going to simplify? Right there, 5 and 100. Okay, so that's going to become what?
50.
Negative 50. Okay, because square root of 100 is 10. 10 times 5 becomes 50. Do the 70s break down? No, I don't think they do. I can't think of any perfect squares that go in there. Okay, we can combine them, and what would we get if we combined them? Yep, 13 squares of 70. And now we can finish this because we just got these two things that we need to combine, and that's it. So if you do one like that, there really isn't anything all the rest of them are pretty straightforward that are in that assignment. We could have something like this. Now this doesn't have any foiling or anything in it, but they do have a couple problems kind of like this. All right, this is all addition and subtraction. Can we add them like they are right now? No, because we got to break them down. All right, we need to simplify them or break them down. So we can't do anything with the 5. What about the 45? Can it be broken down or simplified? Any perfect squares going to 45? 5 and 9. Okay. So what is that going to become? Good. That's good. That's awesome. 6 square roots of 5. Good deal. Okay, what about the 20? Can we break that one down? 4 and 5. Okay. And what does this become? 6 square roots of 5. Okay. So now we can combine stuff because they're all the same. So we have 1 square root of 5 plus 6 square roots of 5 minus the 6 square roots of 5. What's our answer going to be? Just a square root of 5. Okay, these basically cancel out. Okay, so there'll be a couple ones like that, and there'll be a couple ones like that kind of your test too. All right, so strategy here is see if you can get them to, simplify them, break them down so we get the common number underneath. It's very much like a fraction. You got to have a common denominator, and here you got to have a common number underneath the radical. Same idea. And even with a fraction, you never add the bottoms. Okay, so like with a fraction, when it's 2/7 plus 4/7, we know that's 6/7. All right, so when it's 2 square roots of 7 plus 4 square roots of 7, we get 6 square roots of 7. So it's very, very similar idea. Oh, any questions on any of that we did before we do one last thing out of this section? The last thing that they have is something like this. Okay, where they put a squared up there on the top. So whenever we see that, we always want to write it twice. And now just FOIL it. I think 17 squared is 349. It's going to end up being 17 either way. So we're going to add that. But if that's not any different than foiling, you're just writing it twice and doing it. Okay, still simplifying this down. Combining those, not any real different. Any questions on that? The 17 squared? I think it's 17 times 17 is 349. It's 289? I was a little off there. I was thinking it was, I wasn't sure if that was high enough. Thanks. Well, here's what happens. So when you take the square root of the things that are the same, it just ends up being that number.
Oh.
Okay, because the square root of 17.
Okay.
Yeah.
Okay, got it. 17 and then minus 17 and then I get.
Right, right. Okay, the last thing we're going to take a look at here is called rationalizing the denominator, or sometimes just called rationalizing. So in this case, we're going to take a look at division, because a couple of you asked some questions about that already from on Tuesday's assignment there. So what happens if you have 3 over the square root of 6? All right, so you can't do anything with the 6, all right? But in mathematics, and I'm not exactly sure why, but you cannot have a square root or a radical in the bottom of a fraction, all right? So no square roots or radicals in bottom of fractions. Okay. Kind of like having no negative exponents, it's the same thing. It's not proper, so they don't want that there, so we have to get rid of it. All right. So to change this, we're going to do something called rationalizing. Basically, to rationalize, we're going to multiply the top and the bottom of the fraction by what is on the bottom. Okay? So we're going to multiply the top and the bottom of the fraction by the square root of 6. You have to do both here. Alright, you just can't do the bottom and not the top, because then you're changing the value of the fraction. You're basically just multiplying it by 1, but we're making that value equal to the square root of 6 over the square root of 6. So now we get 3 square roots of 6 on the top, and we're going to get the square root of 36 on the bottom. But the square root of 36, we know what that is. It's just 6. Okay, so now we do not have a square root in the bottom of the fraction. And by multiplying by this, okay, that guarantees that. Because it's always going to take and get you back to this number that's underneath there. Kind of like with the 17 thing. Okay? So that's why you do it. And it's called rationalizing, because you're changing it from an irrational number to a rational number. Alright? That's why they call it rationalizing. This isn't done though, because you can reduce here. Okay, you can't reduce these because this is underneath the radical and this is not. So that we cannot do. But since these are both outside, or they're not in radicals, then we can reduce those, and we should reduce them, because it's always simplify. Okay, so that's called rationalizing. So, this one looks like 10 over the square root of 10. What are we going to multiply top and bottom of this by? Square root of 10, yeah, because that's what's on the bottom. So we're going to get 10 square roots of 10 on the top, because we can't, this is not inside a radical, so we can't multiply them. What are we going to get on the bottom? 10, because what's the square root of 100? 10, right? Those 10s are going to go. Leave you with that. Okay, that's called rationalizing. And it doesn't matter what's on the bottom. You're always just going to multiply by whatever that is. Now sometimes you get something like this, alright? Gets a little more complicated. You're still going to rationalize. What we're going to do is we're going to multiply by what is called the conjugate. And if you take Math 95, you'll hear that word again, conjugate. So the conjugate of a number, like this, or an expression, the conjugate of this expression would be a minus the square root of b. So the only thing that changes in a conjugate is these two signs. Okay? They change. So if it's minus, they change to plus. If it's plus, they go to minus. It's called the conjugate. Again, you'll see it if you take Math 95 and higher. It comes up in a couple different spots. So we're going to multiply by the conjugate, which would be 1 plus the square root of 3, 1 plus the square root of 3. And what happens, you'll see what happens while we do it. So here we're just going to multiply this. And then we're going to FOIL the ones on the bottom. Okay, so we're going to FOIL that. So let's walk through that. So we're going to get 1. We're going to get 1 square root of 3. we're going to minus the square root of 3, and we're going to get minus the square root of 9. Okay? So the reason why you multiply by a conjugate is because what that does is it forces these things to be opposite, and they go away. So the square roots go away. The top is done. The bottom, these square roots are going away. And I always get the square root of some perfect square there. In this case, it's 9. Square root of 9 is 3. I'm going to go to this 1. That gives me a negative 2. This is done because I can't simplify anything. Now you don't have to multiply by a conjugate on the other one because it doesn't have a number. It's just a plain old square root. Okay? So it doesn't matter. You actually can, but it isn't going to make any difference. Same thing, so here we're going to do some rationalizing. What are we going to multiply the top and the bottom of this one by? 2 plus the square root of 6. Yep, 2 plus the square root of 6, good job. So let's do the top. What are we going to get on the top? Yep. Now we got to FOIL the bottom, so let's just step it out. So what's our first number? 4. What's our second one going to be? 2 square roots of 6. Good. And then we're going to get, okay, and then minus what? Right. And we know we know what that's going to be. It's always going to be a perfect square. Always going to be a perfect square. These are always going to cancel out. That's the whole idea. So those are gone. This becomes a negative 6. So what's our answer on the bottom? Negative 2. Now, we can reduce this. This negative 2 goes into here and into here. Not into the 6, though. So negative 2 goes into 16, 8. Negative 2 goes into 8, 4, and leaves us with that. Okay? It goes into both of them. And you might say, well, why does it go into both of them? Isn't it canceled? That's because this is the same as 16 over negative 2 plus 8 square roots of 6 over negative 2. Okay, so if we split it up and wrote it as two fractions, that's what that would look like. And that's why that negative 2 goes into both of those things.
And it can't go into the 6 because it's part of radical.
The radical's in the 6, right. 6 is inside. Okay. Now the only thing that I'm looking at it right now on the assignment, the only thing that they do that I didn't do was they had things like this where they had the square root of 3/7, okay? But you're still going to make that this and then rationalize. Okay, so it's not like it's anything different. You can't reduce anything there, so alright. You just rewrite it in this form and then rationalize it. Okay, and there was a problem like that sort of on your last assignment where we could have rationalized it. I think Corey asked me about it, and I saw it and I go, okay. I think that was when it was 24, was it 24 over 8, right? I think it was this guy. Yeah, and you reduced it. And I said, yeah, that's good. But we could have rationalized it. We got the same answer. Okay? We could have just did this and then just rationalized it. So it really doesn't make, you're going to get the same answer. It's probably easier to go ahead and write it as a single square root and then reduce it. Okay, but a lot of times you're going to get ones like this and they can't reduce. Okay, so you got to rationalize it. And if there's a variable there, you put a variable in it. It's not a big deal. So that's everything on square roots from chapter 7. Okay, so we've added them, subtracted them. This is kind of a division thing. All right, we did everything we need to do there. We don't do 7-5. Okay. All right, so what I'm going to do is just go ahead and put a couple practice problems up here as usual. All right, you can go take your break whenever and come back and work on them. We'll go over the supplement, which will take like 3 minutes because it's really pretty straightforward, and take our quiz, and that'd be it. If you want, I can try to, if you don't have any access to Desire to Learn, you can't get their solutions, I'll just go print them out for you. So if there's somebody in here that cannot access that, ask me and I'll try to get a darker copy than that one if you can't read that one. Okay, so let me pause this.